Hello again and welcome to this session. In the previous session, we saw how we are going to develop the software using a model. Now, I told you we are going to develop the model and going to check the efficacy of the model. And once the efficacy of the model is confirmed or checked, you develop the software using model-based system engineering or model-based design. Now, what is model-based design? That is beyond the scope of this particular session. But as of now, you remember that there is a procedure called model-based design through which you can develop the software from the models directly. Okay, this is far easier and far time efficient than writing the code manually. For now, you please note it down. Okay, now once the software is developed, how do you ensure the efficacy of the software? We have ensured the efficacy of the model, the source of software, and now we have to ensure the efficacy of the model. Option number one is you load the software into vehicle and drive the vehicle on the road, which of course is very time consuming. Identifying the right scenario, identifying the right climate, identifying the right ambient conditions. This is very cumbersome and very time taking. Second option is you load the software only into ECU and test the ECU. Okay, this is called hardware in loop. We will be checking, I'll be explaining you what is meant by hardware in loop in the coming this one in the coming sessions. But this is also one options. But don't you think it is even a better option if we can test the software itself in a unique manner? We can isolate the software and test it in a virtual environment which does not require any kind of any hardware, and that procedure is called software in loop. Now let me explain to you what is meant by software in loop in a very clear elaborate manner. So software in loop testing methodology is used to stimulate the interaction between the software components before deployment. So you first identify the take those software components and simulate the interaction or simulate the environment, and it allows for early detection of issues, facilitating faster and more cost effective development cycles in ADAS technology. So once the software is the correctness of the software is ensured, then deployment cycle in ADAS technology become faster. And software in loop is a method of testing and validating code in a simulation environment. Let me explain a more layman language. Software loop is a method of testing and validating code in a simulation environment in order to quickly and cost effectively catch bugs and improve the quality of code. Okay, so this is very important. The purpose is to catch bugs and improve the quality of code. Typically, SIL testing or software in loop testing. Remember, SIL is the abbreviation of software in loop. In day-to-day life, many experienced professionals they just call SIL testing instead of software in loop. They call it SIL testing. So remember, SIL means software in loop. So software in loop testing is conducted in the early stages of the software development process, while more complex, costlier hardware in loop testing is done in later stages. I'll explain to you what is meant by hardware in loop also. SIL is particularly important in the automotive industry as OEMs move towards building software defined vehicles that enable features and functions primarily through the software. Alright, understanding the sentence very carefully. SIL is particularly important in automotive industry as OEMs move through building software defined vehicles that enable features and functions primarily through software. Now gone are the days where a car or automobile conjures up a mechanical device. 30 years back when you see a car, you basically think that car is made up of a mechanical systems, but those days are gone. Not totally, still a lot of mechanical aspects are there, but increasing number of software is being used in automobiles. Slowly but steadily, cars are being called as software on wheels. Software is taking over the automobile to such an extent, and each software program, whether it is related to autonomous safety, autonomous driving, user experience, or other areas, has thousands of specific requirements, and it is not practical to perform manual testing to make sure the software does what it is supposed to do. So as you can understand, within the automobile, lot of standards are there, whether it is safety wise or user experience wise or autonomous driving wise. So doing double checking all the specific requirements is not practical. in a manual way is not practical. And moreover, it is prohibitively expensive. It is criminally expensive and time consuming to physically load software under development into actual vehicle and test drive it for the potentially hundreds and thousands of miles needed to make sure the software works in all types of driving conditions. It may appear common sense, actually. It appears to be very self-explanatory that driving for thousands of miles is very costly. But that was what actually people used to do some 30 years back. Nowadays, because of these concepts like software in loop, this much work is being saved. This much of cost is being saved and this much of time is being saved. What are the key benefits of software in loop? Enhanced testing capabilities. Software in loop offers increased flexibility in testing scenario, enabling rigorous examination of various driving conditions without the need for physical prototypes. Okay, now this is something I already hinted. Without a physical prototype, without actually driving on the road for thousands of miles, we can test the software capability. And of course, cost and time efficiency. By identifying software issues earlier in the development, still significantly reduces both development and time costs related to physical testing. Actually, this appears to be, of course, the initial investment on software testing may be more. For example, this software in loop rig and all these things, software in loop tools may be costly. But once you invest it in a correct manner, you will be saving thousands of dollars of loss, hours of time, days of time, and moreover, you will be risking driving actual vehicle with unproved software on the roads. That way, even testing is becoming safe. Some prominent tools used for software in loop. So what are the various prominent tools that are being used in software in loop? First is MATLAB, a popular choice for developing and testing control algorithms in SIL environment, offering transition from model-based design to code generation. So this is very important. Seamless transition from model based design to code generation. This is what MATLAB is miles ahead of its contemporary tools. That's the reason. And of course, MATLAB has been old there for a long time, almost for 3 decades. So there are many people who are experts in MATLAB. That's the reason many OEMs are preferring MATLAB and Simulink. But along with that, this code generation from model based design is can be excellently done in MATLAB. The other important tool is DSpace views. I'm sure everybody heard of this DSpace. DSpace rigs are very popular in almost every OEM. DSpace rigs are used. A robust tool for SIL simulation, particularly for complex automotive application with support for integration with DSpace hardware for later testing stages. Now DSpace tools can be used for software in loop testing, SIL testing, and also hill testing. The entire hill testing rigs are manufactured by DSpace. And let me reiterate, if at all you are in OEM, there's a good chance you came across some DSpace rig during some simulation. Next is ETAS Asset. And this also is a very important tool. Frankly speaking, I have never come across this tool, but I heard about this tool. ETAS is a very famous company. It's a very predominant company in developing model-based software development and also including code generation simulation capabilities. Now, this is also making foray into the market. And last is not last. Penultimate one is Vector Cano, primarily known for hill testing, but also supports hill testing. Now, what is meant by hill testing? It is hardware in loop, which I'll be explaining thoroughly. But right now, you please note down that Vector Cano is primarily for hill testing, but it also supports in hill testing by simulating network communication between ECUs. So this is majorly used for simulating the efficacy of the communication between various ECUs. Last one is QEMU. I don't know the pronunciation, so maybe so let me safely call it QEMU. A open source emulator that can be used to simulate different process architecture in SIL environment. So this is also one of the famous simulator company which is currently available in the market. And what are the various testing methods? Okay, hardware in loop is an important testing method which I'll be explaining later. And within this software, rapid prototyping also comes into picture. And next is simulated driving scenarios. And what are the challenges in implementation? There are some integrating issues and data handling complexity. Because of the magnitude of data that is being used, data handling complexity is an important challenge that many OEMs are facing. And integration issues, integrating the software modules into real-time world or real-world scenarios, that is also an important challenge. And further challenges which I have noted down here is accurately simulating complex real-world scenarios, ensuring model fidelity. What is the meaning of the word fidelity? Is accuracy. So ensuring the model accuracy, handling the edge cases and extreme conditions, managing large data volumes, designing effective test cases. Sometimes, however efficient your software into loop testing is, if your test case is not correct, then your output may not be correct. Potentially overlooking hardware specific issues due to virtual environment. Essentially, the challenge lies in creating a software realistic simulation that accurately reflects the behavior of the software when integrated with actual hardware while still allowing for the efficient testing and validation. So during integration also, this is a very important challenge. Creating a sufficiently realistic simulation that accurately reflects the behavior of software when integrated with actual hardware. So simulating software is one challenge, but and also integrating the simulating the behavior when software is integrated into the actual hardware, that is another challenge in its own right. So these are the various challenges and obstacles in software in loop testing. Now here you can understand that when compared to real world hardware in loop and software in loop, these are all the various advantages. Reproducibility is quite good. Scalability and viability is quite good. Cost and setup time is quite good. Test kilometers per day is quite good. As you can understand, actually, if you take out the vehicle onto the road, only a certain number of miles can be run and certain number of miles can be simulated. But in the software, this simulation can happen for millions of kilometers per day, and feedback to function developers, and also debug at code level during runtime. These are all the various advantages of the software in loop. Okay, now let me briefly explain. In the setup one, you can see a virtual ECU in simple traffic conditions. Okay, a simple traffic conditions. If this is the software, and you can see it is a very simple condition, simple environment where you are taking only one or two parameters into consideration, and this is also simulating the sensor, simulating the camera, simulating the lidar model. None of these are actual hardware, they are only simulated. And with these simulations, you are with the help of external simulations, you are actually simulating the software to check the correctness of it. And in the simulation 2, you can see virtual ECU with full-fledged sensor fusion algorithm in a virtual environment made by other virtual ECUs. Here, this virtual ECU or virtual software is working in tandem with the various ECUs, whether it is a brake ECU or engine ECU or steering ECU. All these various ECUs are virtualized and simulated through this through the sensors onto the software. As you can understand, in the real world, this simulation is very expensive, very time taking, and despite the extreme care OEMs take during the real time testing, there can some errors can run up, and correcting those errors is very costly affair. But in software in loop, if at all any errors are sprouting up, you can correct them immediately. Okay, now you understand the magnitude of efficiency of this software in loop. Okay, now let's see, next we will see processor in loop. Thank you.